So here at Mining Engineering Laboratory, we have number of facilities, about 4 laboratories. The first laboratory is the computer lab, and we have a metallurgical lab. Then we have rock and soil mechanics lab, petrographic lab, and the geochemistry lab. Under all this lab, we offer different services, which include mineral exploration, groundwater exploration, geotechnical investigations, mineral processing, and sample analysis, as well as processing, especially processing of the results in terms of analysis. In mineral exploration, we also have a magnetometer, which is an equipment which measures the magnetic minerals. So this magnetometer is the handheld one, normally for field work. And in addition to the magnetometer, we also have a geoseeker. So geoseeker is for groundwater exploration. If you want to extract water, or you want to drill a well, this is equipment to use for easy identification of location where you can drill a borehole. Whereby the magnetometer is for exploration of minerals which are related to magnetic anomalies. So this is handheld or field work type of equipment. In addition to magnetometer, we also have resistivity meter. Resistivity meter is a machine which measures the resistivity of the ground. You know, different minerals has different resistivity, and if the minerals has water in it, that means we expect resistivity to be low, because water is a good conductor. So apart from exploring for minerals, resistivity meter is also used for groundwater exploration. So why people should choose the Department of Mining Engineering Lab? We have a number of facilities which some of them are offered with other service providers, but we are more special, especially in the soil and the rock mechanics. Some labs offer those services, but I think in Malawi we're only laboratory which offers rock mechanics. In addition, for the soil mechanics, I think we have new equipment which has been also I can commend it as if it's a state-of-art equipment, and apart from being state-of-art, is well calibrated, and we have certificates for all the equipment in terms of the calibration. So in terms of speed, we are good because most of the equipment are computerized. We have the Traxo machine, which is more or less computerized. Computerized in the sense that when you put in the sample, you don't need to change the parameters by removing the sample. You can just change some parameters within the computer using the software, like the load or the stress on it. You can just change by the click of the button. Similarly, for the soil analysis, I think we have also the Traxo, which is also a computerized type of equipment, which doesn't need like more manual work to analyze the samples. So I can recommend to come to MUBAS to do the sample analysis. We have also expertise, those expertise who have, apart from having the laboratory expertise, but they also have expertise in the industry. They have worked in the industry for long, and we have chain of expertise. For example, we have geophysicists, we have geologists, we have GIS experts, and we have rock and soil mechanics experts. In terms of customers, we work with construction companies, especially those who are working in the big projects like dam construction, bridge construction, even construction of big buildings like mega factories or maybe 4 to 5 story buildings which need geotechnical investigation before the construction. So in terms of our data accuracy, we normally do our analysis in duplicate, so that when we bring the samples, we divide it into two, and we analyze those samples separately so that we compare the results and have reliable results. And in terms of credibility, we are in the process of registering with the SABICAS. SABICAS is a Southern Africa Development Community accreditation services, which is an organization responsible for accrediting all the service providers in the southern, in SADC region. In terms of which parameters should be done in terms of dam construction or road construction, we first ask the client to explain what activity they're about to implement, and from those line of activities we identify areas which needs investigations. So for example, in terms of dam construction, that means you look at the types of soils which are in that area, and we analyze the compaction and permeability, that is in terms of the soils. In terms of road construction or bridge construction, then we look at the strength of the surrounding rock in terms of the load which is going to carry, and also the users of that bridge. If it's for local or small area use, that means you expect that the load should be small, and if it's M1 road or big road, that means that road is expected to have larger loads to pass through that bridge. That means in terms of the strength of the materials which is supposed to be used during the construction, needs to be very strong. So we always advise customers which parameters to take into consideration when constructing that infrastructure. When a customer come to our office or inquire about our services, we normally share a brochure on list of activities or services we offer, and if he is not sure, we discuss and advise. If he is convinced, he can involve us to go to the field to collect the samples, and when you collect the sample, then we bring it to the laboratory, and after we bring the sample to the laboratory, that means those samples need to be sorted, and after sorting, we do sample preparation. After sample preparation, then we do sample analysis. Our analysis is normally done in duplicates, so we advise the customer to bring a lot of samples, a good number of samples. If the analysis, if the sample collection is done by the client himself, but if it's done by ourselves, we normally make sure that we have enough of samples to do the duplicate analysis. So here at MUBAS, we have a state-of-the-art equipment, especially in rock mechanics and soil mechanics. And I can assure you, this is a machine which you cannot find in the SADC region. At this moment, let me ask our technician to take you through our laboratory services and equipment.
Here at MUBAS, we test UCS for rocks. UCS test is the test whereby we normally want to know the strength of the rock. But for us to achieve that, we have the machine, that is the rock saw. So this machine is it's a nice machine, one of the machine that I can say it one of the highest quality machine that produce the quality when in terms of cutting. We bought this machine from Italy, and it's a strong machine that is durable, and we rely on this machine when it comes to cutting the rock. But now, how do we achieve that? The process of achieving the specimen which is recommended for UCS test, we start by receiving the samples from clients, especially the core specimen in this shape. We normally receive the longer length, more than this. Then from there, we need to cut it according to standard. We normally use STM standard, which is its ratio is 1:2, whereby the ratio, the diameter should be equal to 2 times the length of the specimen, which is required for UCS test. So we normally cut it, the first side, using this machine. Then after that, we measure using the steel rule or the vernier caliper. Then after that, we also do the other side, cutting the specimen, so that we should come up with the recommended size according to standard STM, so that we should be able in line of the standards when testing the UCS. After cutting this, which is the standard for UCS test, now we take it to the grinder to come up with the end flatness. But now, this test is comprises with the construction industry. We normally assist clients that are doing slab, especially mining lab. We have equipments that slab, especially mining lab. We have equipments that manages to do the UCS test as well as point load on rocks. As I said earlier on, that other clients, they brought to us the core specimen already from the field, but others, they also come with the rock borders. So if they bring the rock border like this one, we also manage to come up with a specimen like this using the coring machine. So on this coring machine, we have different diameters of bits, whereby we have the smallest one, which is 42 millimeter in diameter, and following by the other one, which is 60 millimeters, and there's another one a bit bigger, which is 80 millimeter in diameter. Then from these bits, the client chooses the diameter that he wants us for us to conduct the test on his specimen. Now, we take this rock border, put it on the machine, then we drill using this machine, so that we should come up with a specimen which is a core specimen in a cylindrical shape. Then after that, we take it to the rock saw to cut according to the specified size according to standards. Yeah, after achieving the standard size from the rock saw, now we need to do the end flatness. But for us to achieve that end flatness, we use the rock grinder. So this grinding machine, we normally mount our specimen on this, and with the machine, we normally grind according to size, so that we should be able to come up with the end flatness, which is very, very smooth. And with that, we'll be able to do our test on the compression machine, so that we should come up with the UCS value of this rock. This machine is the one that we normally use to achieve the end flatness. It's a nice machine. We bought it from Italy. And in Malawi, it's only at MUBAS that we have this machine. And we advise you clients that use MUBAS, so that you should have the results which have high accuracy. From sample preparation room, after we are satisfied that our specimen has been cut according to standard, especially the height and satisfied that it has been grinded on the ends. So we take it to this room to test its hardness or its strength. But now, before we actually put on the UCS machine, we need to test for flatness and straightness. So for us to achieve the end flatness, we use the dial indicator in combination with the V block. So we check both end flatness and straightness. After the sample has qualified according to standards, we take it to the machine for compression so that we should be able to check the strength of the rock. Now, when you take it to the machine, first of all, we need to check its mass, because the diameter we know it, the height we know it. So we take those parameters and put it into the computer. So after putting it in the computer, setting all the settings, then we command the machine to what? To start testing. So this machine has a capacity of 4,000 kilonewtons, meaning that each and every rock on earth we can break it, we can test it. And it's a machine that is state of the art, because in SADC region, it's only MUBAS who has such machine. Now, after commanding the machine, compression, then it breaks at a certain point where it reaches the stress, the maximum stress at the strain. And these three parameters are the ones that a client needs. For example, maximum load, maximum stress, as well as the maximum strain. But this machine does several things. As I mentioned earlier on, UCS. Then there's another test that we do that is confined compression strength. Then there's another part that we normally do is testing cubes, bricks, and hollow blocks. But to summarize it all, this machine has three softwares. The first software is Adventist, the one that helps us to test UCS. And the second software is CellComp, the one that helps us to test the confined compression strength. And there's another software which is Data Manager, the one helps us to analyze the cubes, bricks, hollow blocks. So this is mother of the machine, because it's one of the machine that has several. We can conduct several tests on this. And as I said earlier on, it's one machine that is within the SADC. Only MUBAS has it. So now, we encourage you clients, the ones that are in the construction industry, the ones that they normally construct bridges, tunnels, dams. You can bring your samples here. We can test for you with a higher accuracy. So there's no tampering with the results. After the machine has analyzed, we just go straight for printing. So no tampering with the results. We can assure you the higher accuracy of results. Here at MUBAS, we also have the laser particle analyzer. This machine, we normally use it to check the particle size distribution of the sample. It's an intelligent machine that it analyzes sample within 5 minutes. This machine, how it works is we normally take the sample into a spoonful size into the machine, and from there it does itself all the work. It takes water into the machine, then from there we put the sample. After that, closing it, commanding it to analyze. So we. But now, this is a very important machine, normally for control. For example, you can have cement. For you to know the grade of cement or the size of the particle cement, the fineness, we use this machine. As well as whether you're using paint or for example, like maybe to check the fineness of the Nzuzu coffee, we normally use this machine. So we advise most of the clients that they want to check the control of their products, especially in terms of the fineness. So the machine analyzes the particle size from 0 to 2000 microns. So we are urging clients, the ones that they normally want to know or the one that they want to control the grade of their products in terms of particle size. Here at MUBAS, we can do that. Within 5 minutes, you cannot tamper the results. After analyzing, then we just command the machine to print the results. So here is the way how the results will look like. The graph will print itself. It checks all the particle sizes that are in the sample will be checked on this paper sheet. Yeah, so this laser particle analyzer is the machine that check the particle size on the sample. But we are recommending most of the construction industry, the ones that they normally use cement for construction. For you to have to check the quality of the cement, we advise you to come at MUBAS, so that the quality of cement determines also the quality of the product or the job that you have done. The bigger the sizes of the cement, it normally has the poor quality of the construction. But when you have the fine one, that much better for you to have a nice construction. But now, come with different products apart from cement. You can come with lime, you can come with paint. We are also able to analyze the particle size and check the quality or the grade or the standard that is required for construction. So here at MUBAS, we also do triaxial test of soil. But for us to achieve that, we have the machine, as you can see. This is a triaxial machine. It starts from there where there's a deaerated water tank, and there's a pressure board where we adjust our pressures. As you can see over there, there's cell pressure and back pressure, as well as a device for volume change. The whole assembly, we use it for testing the soil, the test which is called triaxial test of soil. But how do we do it? First of all, we need to prepare a sample. And that sample has to be in a core shape, a cylindrical, that is, which has dimensions of 38 diameter and the height of 75. So we take that sample, put it in the tube, and put in inside the cell.
In OBS, something
so
like this, what you're seeing right
the
now.
sample itself is inside the lab, and surrounded by water,
and then
which is
text,
inside this glass cell.
Scroll,
now we pressurize
it
so that we should be able to acquire data using the software, Datacom software on the PC.
By the way, you can go ahead and select the font that you like. You can customize
we normally have
it
3 samples,
for now, we're just gonna keep it simple
3 specimens for each and every sample.
Okay. So right now, as
the first sample, we pressurize it at 50 kPa. The next sample, we pressurize it at 100 kPa. The third sample, we pressurize it at 150 kPa.
If you want it to go
so
over, it doesn't matter,
after pressurizing all these samples, this machine, there are sensors that help us to acquire the data using the Datacom software to acquire the data. So first of all, there is displacement, the one that indicates the change in height, and the second one is the pressure, the one that records in kilonewtons, and the third one there is pore pressure, the one that gave us the data for pore pressure, as well as the volume change.
and then we're gonna
So
add a scroll effect.
after we are
So
all
we're gonna go
set,
here where it
then
says scroll.
we start
Click to
our
that.
test
You don't have to
by
name it,
allowing
you
the
can
machine
keep it scroll. And then
to
here
compress
where it
the
says
sample which is
horizontal
inside the cell.
speed, this is what we need.
So
Just,
while
play with the slider
the sample
and
is
choose the
compressed,
speed that
here
kinda looks
the
desirable
PC is also
and
what
it's not too
acquiring
fast,
data
but also
using
like
the
not too
datacom
slow.
software.
Something like this
Then
looks good to
after
me. This is gonna be
acquiring
subjective,
data, we
depends on
process
what
the
you want.
data
Also, you want to make sure you
to
check
come up with
loop,
the test
because
report.
If you don't check loop, it's just gonna
On the
stop
test
once
report,
and it's gonna stop.
there
So
are
you don't want that. All right. So you can go
parameters
ahead and
that
check
the
loop.
engineers
And once
need
you're done,
for,
you're gonna go ahead and click
for example,
close. And as you can
there is
see, our
the
text
cohesion
is scrolling
of the
right
soil,
now,
there
and
is the
it's gonna
internal
keep
angle friction,
looking. Now, if you want, you can
there is
add a
pore pressure,
background, make it look
as well
nice,
as
all the
volume
good
change.
stuff. But for
So
now,
these
we have
parameters
scrolling
are the
text.
ones
Make sure
that
you
engineers
follow
need
for more live
when they are
streaming tips
designing
like
their
this one.
construction.
How to add
So we
scrolling
are
text
encouraging
in
you
OBS,
clients that
something
you
like
should
this, what you're
come
seeing
to
right now.
MUBAS
First, you want to go to the
Geotechnical
scene where you
Lab,
want to
mining
add scrolling
department.
text.
We
Under
have
sources,
the
hit
state-of-the-art
sign,
equipment
and then choose text. You can
that
name
will
it
have the high
scroll,
accuracy
and then click
of
OK.
results,
Now what we need
so
to
that you
do
should
is
be
we
able
need to bring in some
to
text
help
here.
you
So I've
in
just got some
your
text here that I
infrastructures,
just
whether it's
copied and
designing
paste just
and
for the
whatever
sake
you want
of
to
this
use
video.
with the
By the way, you
results.
can go ahead and select the font that you like. You can customize it the way you want. But for now, we're just gonna keep it simple and click OK. So right now, as you can see, it's kind of oversized. We can go ahead and resize it and then make sure it fits. Again, it doesn't have to fit the screen, by the way, but if you want it to fit the screen, you can make it fit the screen. If you want it to go over, it doesn't matter because it's gonna be screen. So, the only thing that I like to do add the scrolling text. Under sources, hit the plus sign and then choose text. You can name it scroll and then click OK. Now what we need to do is we need to bring in some text here. So I've just got some text here that I just copied and pasted just for the sake of this video. By the way, you can go ahead and select the font that you like. You can customize it the way you want, but for now we're just gonna keep it simple and click OK. So right now, as you can see, it's kind of oversized. We can go ahead and resize it and then make sure it fits. Again, it doesn't have to fit the screen, by the way, but if you want it to fit the screen, you can make it fit the screen. If you want it to go over, it doesn't matter because it's gonna be scrolling and looping, so no problem. You can go